This week's topics are functions and graphing, and we'll practice graphing on the graphing paper. Before we get going, we need to know some terminology. So relationship. It's basically a relationship between two sets of information. So for example, if you think of people, individuals, and their heights, there's a relationship between individual and the individual heights. The function is a well-behaved relationship. What that really means is that there's a one-to-one relationship. So for every single person, that person only has one measurement for the height. It can be any two or more number of heights. So, two more words, the domain, and then the range. The domain is basically the collection of inputs. And then the range is the same thing except it's outputs. And I can show the domain and the range in terms of a table. So let's say domain, range. So for example, if you have this relationship, it is a relationship. For every input, there's an output. But this is not a function. Because for a single domain, there are two possible outputs. So that violates the definition of a function. It's not a one-to-one relationship. For 0, there are two outputs. So it's not a one-to-one relationship. So for that reason, this is a relationship, but not a function. On the other hand, if I give you a table like this, this is a relationship and a function, because for every single domain value, there are different ranges. As you can see that there's a one-to-one relationship. And then you might notice there are duplicates, the 5 and the 5. It is okay to have duplicates in the range because -1 has one output which is 5, and the 1 has one output which happens to be 5 at the same time. It's like saying two different people with the same height. That's okay. So this is the function and then the relationship. So that's how you tell the difference between the relationship and the function. How do you know if a function, or if the graph, given the graph is a function or not? So the relationship could be described in the graph. To see if a graph represents a function or not, there's a test called the vertical line test. It's the easiest test in the world. It says if you have a graph, draw a vertical line anywhere. And if the vertical line touches the graph, whatever the graph is, only once anywhere, then the graph represents a function. Otherwise, the graph is not a function. So for example, if I give you a graph like this, is that a function? Yes or no? The test says draw a vertical line anywhere. It really doesn't matter anywhere I draw the line because it crosses the graph only once anywhere. So this graph represents the function. How about if it's a circle? Well, in this case, no, it's not a function because if I draw a vertical line, say here, the vertical line touches the graph twice. That violates the vertical line test criteria. So this is not a function. So let's learn about how to graph something. Graphing. So if you go to page 4, you see the basic of the graph. So the graph, before you know how to do that, you have to know what this is. You've seen this already. This is called a number line. Each line represents the number, and if you go to the right, that's positive numbers. If you go to the left side, that's negative numbers, and then this is smaller and this is bigger. If you intersect two number lines vertically, then you get a graph. Okay. By definition, the horizontal line, that represents the x values, and the vertical line represents the y value. Okay. So say I draw a point here, say here, this point here. Okay. What's the address for this particular point on this graph? Well, in this case, it's 1 and 2. The 1 represents the x value, and then the 2 represents the y value. So starting from the 0, 0, the origin, or the center, I move to the 1 to the right, and then move up twice, 1, 2. So 1 for x, 2 for y. It's like a Pac-Man. You can only move left or right or up or down. So wherever the point is, start with the center, move to that position, and then count how many there are. It's called the ordered pair because this pairing is always in alphabetical order. So you always know the first number represents the x value, and then the second number always represents the y value. So that's called an ordered pair. Another thing you should know is if I have two lines intersecting each other, you see there are 4 corners, here, 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 here. And they're each called quadrant. And you go counterclockwise. So this is quadrant 1, 2, 3, and then 4. So if I ask you, draw a point somewhere in a quadrant 3, so we draw a point somewhere over there. Okay, 1, 2, 3, 4. So let's practice graphing some of the points. I'll do, say, 1 and 5, negative 8 and 4, negative 3, and negative 7. So 1 and 5 would be 1, 2, 3, 4, 5 up here. That'll be 1 and 5. Negative 8 and then the 4. So I need to draw a point where it's negative 8. Extend this a little bit more. 1, 2, 3, 4, 5, 6, 7, 8. And it's positive 4, so I'm going to go up. 1, 2, 3, 4. So it's somewhere over here. That's negative 8, 4 up here. And if I do negative 3 and then negative 7, I need to extend this a little bit more. Negative 3, 1, 2, 3 in the negative 3 direction. And negative 7, I gotta go down. 1, 2, 3, 4, 5, 6, 7. So this is the order pairs negative 3, negative 7. The reason we learned the graph is that the equations or functions could be represented in a couple different ways. with the graph, equation, or word problem. So your job is to be able to go from graph to equation, words, or backwards. In other words, if I give you a graph, you should be able to give me an equation and or describing words. If I give you an equation, you should be able to draw the graph, describe the equation in words. Or if I give you a word problem, you should be able to give me the equation and or give me the graph. So let's practice reading the graph. If you turn to page 5, you see 3 graphs. Graph A, that looks like this. B, that looks like this. And then C, where it's like horizontal. So, Washington High School is having an international food fair. Suppose you have 50 tickets. A bowl of Siamese Asian noodle soup costs 5 tickets. Use this graph to answer the questions. So, which graph, A, B, or C, will represent the number of tickets you have left after buying a certain number of bowls of Siamese? Well, that would be graph B. Because as you buy more bowls of Siamese, you have less tickets, so it's decreasing. Which graph shows the total number of tickets sold or tickets paid? Well, more tickets you sell, the number of tickets you got, so it's increasing. So this is going to be B. And which graph shows the cost of an nth? So it doesn't matter which bowl it is. Nth bowl of Siamese. Well, it doesn't matter how many bowls you buy. Each bowl will cost you 5 tickets. So it's constant. So that represents situation C. So another thing you might notice is that I use the word increasing. So this is a slope. So by definition, if the graph goes from bottom left to upper right, it's considered to be increasing. So this would be decreasing. And this would be horizontal, so that's constant. Nothing, it doesn't change. So how do you graph equations? Well, there are a couple different ways to graph equations, but we'll start with the simple one, using a table. Make a table. So graphing equations. Make a table. Calculate at least 2 values. Well, we'll pick 2 values of x and solve for y. And then plot the points. And graph. So if I give you, say, graph this equation, make a table of x's and y's. So here's the key. If you're graphing an equation, you can pick any x's you want. So why not pick some easy ones? Why make it hard on yourself? So let's pick some easy x's. So here's my recommendation. Always pick a 0. Okay? 0 is easy. Anything multiplied by 0 is 0, so that makes the calculations easier. Pick a small positive number, say a 2 or 3, whatever. Because if you pick a large x, y could be big as well, and it'll be out of the range of the graphing paper. So to keep the y's relatively small, I recommend you pick small positive number. And another small negative number, that's different from positive number, so 2 and then negative 1. If you remember from geometry, you only need 2 points in order to draw a line. I recommend you go do 3, because it's really easy to make a calculation mistake when you're calculating something. And you even know that you made a mistake if you only have 2 points, because you still have a straight line. But if you add the third point, you might, if you made a mistake, you see a kink in your graph. That's just a giveaway that you made a mistake somewhere. So that will prompt you to recalculate and fix your errors. So for graphing, I recommend 3 points, a 0, small positive number, and a small negative number. So what I'm going to do is plug in these numbers into the equation and figure out what y is. Okay, let's plug in 2. So that's going to be negative 2, 2 plus 5, negative 2 times 2, that's negative 4, plus 5, negative 4 plus 5 is positive 1. 0, 0 times negative 2 plus 5. Well, this is going to be 0. Anything multiplied by 0 is 0, so that's going to be 5. Negative 2 times negative 1 plus 5. So that's going to be negative 2 times negative 1, that's 2. Plus 5, that's going to be 7. Let's see if my calculations are correct. So here's your coordinates. One, two, three, four, five, 6. So that's the first one, 2, 1, 2. Where does it go? 2, 1 up here. 0, 5, 1, 2, 3, 4, 5. Negative 1, and then 7. So negative 1, 1, 2, 3, 4, 5, 6, 7. Okay. So it looks right because it's a straight line. So that's the graph of y is equal to negative 5x or negative 2x plus 5. So let's do a second one. X plus 2y is 8. So again, I'm going to pick some simple numbers. Why not use the same one? 0, 2, negative 1. Okay. Slightly different because it's going to be 2 here. 2 plus 2y is 8. Okay. So 2 plus 2y is 8. Subtract the 2. You get 2y is equal to 8. So that makes y 4. Let's do 0, plug in 0. So that makes it 2y is equal to 8 because the x disappears, it's 0. That makes y to be 4. Oops, I think I made a mistake up here. So 2 times 2y, oh, that should be 6 here. So I knew I made a mistake because so 3 here, 4 here, Okay. Let's do negative 1, and hopefully I get it right this time. Negative 1 plus 2y is 8. So negative y plus 2y is 8. Add 1, add 1. 2y is 9. So y is 9 over 2, so about 4.5. Okay. So the order pair will be 2, 3, 0, 4, negative 1, 9 over 2. So let's graph that, see if it works. So 2 and 3. 2 and then 3 here. 0 and then 4 up here. Negative 1 and then somewhere over here, somewhere between 4 and 5. So yes, it looks it's right. So there's your graph there. So if I expand this a little bit. So this is a graph of x plus 2y is equal to 8. A key concept in graphing is the intercepts. What are the intercepts? Well, it's the point where the graph intercepts the axis. So that's an intercept here. Somewhere over here, that's an intercept. This one is called the x-intercept because this is that's the point where the line crosses the x-axis. So this is x-intercept. And naturally, this one crosses the y-axis, so this is called a y-intercept. And you should know how to calculate intercepts, x and then y. How do we do that? Well, if you look at the graph, say an example 1, you notice that if I draw a graph anywhere, the graph has to intercept this vertical line. Same thing for here, over here. So any point on this axis could be a x-intercept, and then any point on this vertical line could be a y-intercept. If you think about it, any point here, the y value will be 0 because it's always going to be on this line. Similarly, for any point on this vertical line, what's the value of x? Well, x is always 0. So we're going to use this fact where that if it's a y-intercept, x is always 0. And then if it's an x-intercept, the y value is always 0. We use that to advantage to figure out the intercepts. So find the intercepts. Okay. Say I give you this. I need you to find the x-intercept. I'm going to write x-int, short for intercept, y-int. You're always going to get half credit for this because you already know that for x-intercept, y is always going to be 0. So 0 here. And for y-intercept, you know that x is always going to be 0, so 0. So the answer will be in the ordered pair form. One for the x-intercept and one for the y-intercept. You already know the half of the answer. Great, huh? So what happens for x-intercept if I plug in the y, or 0 for the y, so 0 equals 2, negative 4x plus 12. Add the 4x because I want to get rid of this 4x here. So 4x is 12. That makes x to be 3. 3. Let's do y-intercept. The y-intercept is the easiest thing, as you see. Let's say I plug in that 0 for x's. So what does that mean? Y is equal to, this goes away, 12. Boom. It's this number right here, 12. So if the question says find the intercepts, you always have to find two of them, x-intercept and then y-intercept, for a complete solution, complete answer. And you already know the half of the answer, 0 here, 0 here. And your job is to figure out the x value here and the y value here. Really the hard one is this. This one is always easy because for every single problem, if the equation is in this format, y is equal to some x plus a number, it's always this number. So let's do a different one. 2x minus 4y is 8. I already know this much. So let's figure out the x-intercept, x value. I'm going to plug in the 0 where the y is. So 2y's equal to 8. What's your x? 4. 4. How about the y-intercept? Well, it's not as easy as the previous one, but it's still pretty easy. Plug in the 0 where the x is. X's go away. Negative 4y is equal to 8. Divided by negative 4 here. Y is negative 2. Negative 2. So that's your complete answer. So for this week, you should be able to graph something. If I give you the equations, you should be able to give me the intercepts and plot some points. Pretty easy.